So the topic of the notes is solving log equations because we've already solved exponential equations. So now I got to solve logs. And there's two different types of log equations we're going to see. Sometimes we'll see an equation that has a log only on one side of the problem, and sometimes we'll see equations that have logs on both sides. And for today, we're going to focus on the problems that have a log on one side. So log on one side. So here is our first example problem. We're going to say log base 6 of x minus 4 plus log base 6 of 5 equals 2. So when we're solving a log equation, our first step is to condense the logarithms. So that means that at the very most, you should only have one logarithm per side of the equation. One log on the left side, one log on the right side. So only one log per side. So if you look at this equation, the 2 is not the problem because there's no log with that. But what do you guys notice about the left side of the equation? 2 logs. So we're going to have to write log base 6 only one time. We can only write it once. And okay, so Katie said 5x minus 20. How did she get that?
Since it's addition.
Yeah. Since it's addition, you know, you're multiplying. So the x minus 4 should be multiplied by the 5. And then how did Katie multiply those together? She distributed them. Good. Okay. Now at this point, if we were good at letting our brains think in terms of logs, then we could solve this the way it looks right now, but most of us are not good at thinking in logs. Most of us would probably want to get rid of the log as quickly as we could. So to get rid of the log, we have to undo it. Do you guys remember what the inverse of a log is?
Exponential.
It's exponential, yeah. So step 2 is to do the inverse of the log. So to do the inverse of the log, which is exponential form. Do you guys remember how we put it into exponential form? The Tootsie Roll, or the cinnamon roll, or the cloud thing, or the scorpion thing, circle thing. So which number do we start with? 6. The base becomes the base, and then what do we do? So 6 to the second power equals
5x minus 20.
okay. Yeah, so that's what I would do first too. Immediately I just want to say that 6 squared is 36. And at this point, does that look like an equation that we can solve?
Yes.
Yes.
So are we just finding x now?
Mm-hmm. Yep. So at this point, we got it out of the log equation form. Now it's just a regular equation. We just got to get the x value. So I'll go ahead and add 20 to the other side. And that gives me 56 equals 5x. And what should I do next? Divide by 5. And you can type it in to see the decimal, but I'd say you can go the lazy route and just leave it as a fraction. That works too. So 56 over 5, or I believe it's 11.2 if you type it in.
Yeah.
11.2. Okay. So when we do these, we have to be careful because we did say that for this unit we learned a new type of number that can't be plugged into logs. Do you guys remember what can't happen with a log? Decimals are okay. Negatives are not okay. So that means that whatever you get for x, when you plug it back in up here, you should not be taking the log of a negative number. Your calculator would give you an error if you did that. So if we did 11.2 minus 4, is that going to give us a negative answer inside the log? No. No. So this answer is good. We're not concerned about this answer because it's a positive number. So that will be fine. Okay.
So if we ever get a negative number,
it means it doesn't mean try again. It might mean there's no solution.
Okay.
Yeah. So this was what would happen. Let's say we had log base 6 and we had negative 11.2 minus 4 instead of positive 11.2 minus 4. Your calculator is going to give you an error because you can't do that. Okay, so anytime that happens, when we were to like go back and plug it in for x, anytime you would have ended up having a negative number inside of your parentheses, you have to x out that answer and say that's an extraneous solution. And if that was the only answer that you had, that might mean that the problem was not solvable. There's no possible way to make the equation true. Okay, second example. We are going to do log base 3 of x minus log base 3 of x minus 5 equals 1. So what's our first step? Condense. Yeah, bring down the 1 and then condense this side. We can only have log base 3 written one time. So what does the other stuff do? It's dividing. How do you know it's dividing? Yeah, it's a minus problem. So what should go on the top? What should go on the bottom? X on top. X minus 5 on bottom. So this is actually the thing that you're taking the log of. Okay. And that division problem, that can't be simplified. X over x minus 5 is as simple as it gets. So what should I do next? Yeah, get rid of that logarithm because we don't know how to work with that the way it's written right now. So I'm going to say the base of 3 becomes the base of the exponent. So 3 to the 1 equals... Yeah, 3 to the 1 is just 3. So this is just 3 equals x over x minus 5. And yeah, there's a few different ways of handling this. So one way is just to multiply both sides by x minus 5 to get it off the bottom of the fraction. The other way to think of it is to put the 3 over 1 and cross multiply, because a lot of students really like cross multiplying for middle school for whatever reason. Yep, that's what we just said. So you can do either way. So you can multiply each side by x minus 5, or you can cross multiply. It is totally up to you. Either way, you're going to end up with x equals 3 times x minus 5. So whichever way you chose to do it, that's what's going to happen. So x equals...
How you get that?
So I went ahead and cross multiplied. I said x times 1 is x. And then I said 3 times x minus 5 is 3 times x minus 5. And then I went ahead and distributed my 3. And at this point in the problem, a lot of you guys would tell me to divide by 3. Just take the whole problem, divide it by 3. What's wrong with that? What's wrong with that as far as the x's go? There's x's on both sides. So a lot of you guys have done that in the past. If you saw an x on two sides, you just kind of divided by one of the numbers in front of them, and you can't do that. You have to move this 3x over to the other side. So we can only divide by the number in the front if it's the only part of the equation that has an x. Yeah?
Well, okay, so I'm being kind of slow, but how do you cross multiply here?
So you do the bottom and the top. So I did 1 times x equals x. And then over here I did the bottom and the top, 3 times x minus 5. So this one equals that one. Okay. So these cancel out. And negative 2x equals negative 15. Divided by negative 2. So x equals 15 over 2, which is 7.5. And then we got to go back. So if I take log base 3 of 7.5, is that going to be okay?
Yes.
Yes. If I take log base 3 of 7.5 minus 5,
Yes.
that's going to be okay. That's still positive. So this is a good answer. We got no concerns here. Okay.
So we don't take it down to 7.5, we just leave it, I mean 2.
So 15 over 2, 7.5 are both fine answers. What I would say is if you have a fraction answer where the decimal is nice and you don't have to round it to write it down, you can write the decimal if you're more comfortable. If I had a decimal answer like 0.333333333, I would rather have you write 1/3 because 1/3 is like the perfect answer and 0.333 is rounded. So if you had to choose, I'd rather you have the exact answer, but in this case, it doesn't really matter. Okay. All right, I'm going to do one more to show you guys that, like these ones, the equations that you had to solve were pretty easy to solve. They were linear equations, which means that the x is pretty easy to get all by itself, right? We're going to do one that has a quadratic equation, which means that sometimes as you're doing the problem, you're going to run into a factoring problem in the middle of it, okay? Every so often it happens because as math teachers, we were like, well, we taught them how to factor. They should always recognize it, and they can do it every single time now, right? Or factoring. We're factoring. Okay, so here's the next one we're going to do. Are you guys ready?
Yes.
We got log base 12.
Oh my goodness.
Of 2x minus 1 plus log base 12 of x minus 3 equals 1. Whew, I'm already so excited.
Wow. Me too, man. I'm excited. And I'm serious.
That hurts my heart.
I'm kidding.
All right, so the 1 is not the problem. I'm going to leave that 1 there.
I got it.
What do I have to do on the other side?
You have to condense, but you have to multiply.
Yeah, so it's a plus, so this is a multiply problem. And I've got 2x minus 1, and that's going to be multiplied by x minus 3. And what's our method of multiplying those? Yeah, foil or box? Which would you guys rather do?
Box.
Box. We like the box. So 2x minus 1, x minus 3.
2x squared. Negative 6x. Negative x 30.
Don't you love it when they do the math for you? I didn't even have to use my brain. It was great.
And it's 2x squared minus 7x plus 3. So log base 12.
Yeah, so we've got log base 12. We take all the stuff from the box and just combine like terms. See, it wasn't so bad. We're still okay. We're handling it. Okay, are we ready for the next step?
No.
What is the next step?
Next one we did.
Yeah, now the confusing part is that it's got a log there. We don't know what to do with that, so we're going to undo the log.
It's 12 or 12 equals 2x squared minus 7x.
And this is the point where we realize this equation is not going to be as easy to solve as the other ones because it has an x squared in it and an x in it. And what should that make us think every time we see an x squared and an x? It's diamond? Yeah, we should be thinking quadratic formula or factoring. So when you do the quadratic formula or when you factor, what do you have to have the equation equal?
0.
0. It's got to equal 0. It can't equal 12 to the 1. It's got to equal 0.
12 to the 1 is 12.
Yeah.
So you need 12.
So 12 to the first power is just 12, so we can subtract that over.
Yeah, but not in Sam's, does it? And then you,
What type of factoring problem is this?
you gotta do the slide and
Slide divide, yeah. So take the 2 and the -9.
I didn't even realize that.
Deisha, you doing okay?
Yes.
You sound a little stressed out over there.
I am. Just start singing. It's not time.
Alright, so 2 times -9,
-18.
-18. So we're multiplying to -18 and adding to -7. So we slid the 2 over, right? So -18, that's our first step. And the numbers are -9 and 2. Now, if it was a diamond, we would just be like, all right, x minus 9, x plus 2, we're done.
Correct.
But we're not done because it wasn't a diamond, it was a slide divide. So we got to divide by 2. So the number that you slid over is the number you divide by. Divide by 2, divide by 2. Now this one right here does not divide by 2. So we put the 2 to the front. 2x minus 9. This one divides by 2 though. And all that work and we still don't even have the answer yet.
We know
What?
My grandma said if it takes longer than 2 seconds to do a math problem, it's not even worth it. You're not going to do well.
Yeah, that mentality is not a good mentality. So what are the 2 solutions?
-1 and 9.
I don't like this.
Yeah. This is -1.
And then number 2.
Opposite sign, -1. Now this one, it's the same as up here. The opposite sign of this is +9/2, right? So +9/2. Because if we were to solve this by hand, we would be like, okay, 2x minus 9 equals 0. And you would have added the 9 over, and then you would have divided by 2. So 9/2. Okay. Now we're still not done. Because we have to go back to the beginning and make sure our answers are okay. Yeah, so we have to be careful. If I look at this, if I plug in 9/2, I've got 2 times 9/2 minus 1. Is the 9/2 okay for the first one? Yes. If I do 9/2 minus 3, is 9/2 okay for the second one? Yes. So 9/2 is a great answer. We like that one. The other one does not work. You're exactly right. So on this, did we steal your thunder, Laura?
No,
Okay. What was your question?
notice how you wrote it. It looked like for x plus 1, it looked like it was squared. And I was like, why would it be squared?
Oh no, it's not. So if we do 2 times -1 minus 1, we get -3, and that would mean we were trying to do log base 12 of -3, and if I typed that in my calculator, what would my calculator say? Say error. It's not a good answer. So mathematically we did solve for it, however, it's an extraneous solution. So even though I found 2 answers for this problem, there's actually only 1.
What does extraneous mean again?
Extraneous is like extra. Extra answer that doesn't work. Okay. All right, I got some problems for you to try. Are you ready? I got some problems. Here's the first one.
Don't give us the problem.
I mean, otherwise we're going to have to.
So when you guys look at these first 2 problems I just gave you, what are you noticing already? They are already condensed. They are already condensed. That means you don't have to narrow it down to 1 log on a side because they already have 1 log on a side. So now we're going to do 4, I think. So with these 2 problems, since they are already condensed, what's your first step?
To change it into
To Tootsie Roll to get it into exponential form. Daisha, that was your moment to start singing. That was your moment.
You understand?
Okay.
Does the x minus 9 mean anything? Because you can
For now, go ahead and do your Tipsy roll and just leave it in the problem. You'll be able to yeah. Well, but you should not be taking home very many problems, like 3 at the most. You should only take home 3 problems at the most. Okay, this last one, I just want to see if any of you guys can figure it out. This last one is like the challenge problem. I think you can do it.
Do it.
Oh, it's the same as number 1. X squared.
No, it has an N.
What's the N?
ln. What does anyone remember what ln means? Log base e. That's your hint for number 4. Log base e. That's your hint for number 4. Log.
So would E be the answer?
Yes, it would.
Okay.
Let me see.
That makes sense.
I got the
Right.
Let me see that 2 6 roll.